Well, actually, I think the recent news of OMG, what's interesting is to compare it to the past. So we started in object computing and distributed object computing. We helped create the middleware market, control the hype around object computing. And then we made a big change in the middle of the 1990s and said there's something to do with modeling here, which will create enormous opportunities in the computing business. And we adopted our first modeling standard, the Unified Modeling Language. But actually the bigger change, which didn't get as much visibility in the late 90s, was our move into vertical markets. And now 85% of all OMG standards are in vertical markets like healthcare, finance, telecommunications, manufacturing, civil government, military communications, command and control, automotive design, all sorts of things. So what's new this year? We've got a lot of exciting things going on in software quality, where the first standard came out in 2013, automated function point count. And in 2014, we're going to see quite a few metrics of good and bad quality software coming through from our Consortium for IT Software Quality through the OMG standards process. This year, we'll also see standards for automotive dependability analysis, which has been, if you'll pardon the pun, driven by Toyota for the last year and a half. That's quite exciting. And we also will be launching our new standards effort in natural resources, especially focused today on oil and gas. So there's always plenty of things going on. We're also starting to invest heavily in China, where we're seeing growth. The first major Chinese company has come in, that's Huawei. Not just because of their interest in telecommunications, but actually their interest in software quality, their interest in cloud computing, and so forth. Well, I think that has nothing to do with OMG per se. Obviously, the value to using standards is it gives you choice. It allows you to change vendors. And it brings down the cost because you have fewer approaches to solving a problem. You have lower training costs, and the switching costs go to zero because you can switch vendors whenever you want. That means that the vendors are now going to be competing based on the quality of their offerings, the cost of their offerings, the support for their offerings, and so forth. You know, it's actually a lot to do with how we invented OMG in the early days. We're a standards organization, but different than others in many important ways. I think the single most important difference of OMG is that our membership is half vendors and half users. There are also government agencies, which are users, and there are universities and research institutions. But the problem with vendor-driven standards organizations is they develop standards that nobody cares about because they don't meet the requirements of real users. The problem with user-driven standards organizations is they publish requirements for products the vendors can't deliver. We balance that half and half. Our vendors and users and academics and research institutions and government agencies work together to develop requirements, and then any vendor can propose a specification. So our standards process is different too. That's, I think, the best explanation for our longevity. There were many standards organizations created in the late 80s, Corporation for Open Systems, Ex-Open Company, Open Software Foundation, and so forth. We're the only one that still exists with the same name and same focus. And that's because we have this balance between users and vendors, and we have a process that operates really quickly. CIOs, by participating in standards, can make sure their requirements are known and can see those standards before the products hit the street and be ready for them, be ready to take advantage of them. That's an enormous value. The interesting thing about the automated function point standard, which came out just about a year ago now, is that not only was it adopted through the usual OMG standards process of vendors and users coming together to define requirements, and then a standard coming through a very rapid adoption process, but the group that was pulled together to develop the specification, which is called the Consortium for IT Software Quality, CISQ or CISQ, we also run that group. We bring together those vendors and users, mostly users in fact, that want to have software quality metrics that are consistent and automatable. Because if they're inconsistent, they don't give you the same answer twice. That's obviously not valuable. And if they're not automated, that means they're done by hand, they're expensive to do, and therefore not done, or at least not done often enough. So this idea of automating those functions, automating tests, automating defect tests, automating complexity and size metrics is extremely important, both to CISQ, which is obviously a group of companies that cares the most about it, but to OMG, because those quality standards have an impact on everything else we do. The obvious business case for automated function point is outsourcing. So every outsourcing contract has some sort of metric of quality. Quite often that metric of quality has something to do with measuring the process used to develop software rather than the actual resulting software, the artifact. As someone who came from the manufacturing space many years ago, I always find this amazing. Boeing, for example, certainly has processes for integrating its own working processes with the processes of its subcontractors, its suppliers. In fact, in Boeing's case, they call it working together. But when the parts come into the factory to be integrated into the aircraft, they are tested. They're tested for tensile strength, they're measured for size, they're crushed, they're expanded, they're tested before they go into the aircraft. And yet, the same organization, Boeing, will contract out software development, and when the software arrives, simply integrate it in and hope it works. This makes no sense. That's clear that we need to have ways to improve the quality of software development processes. For example, what CMMI does. But that's not enough. You've got to measure the result. Otherwise, how do you know whether the process is actually delivering quality? So what does it mean for CIOs? Number one, they can actually now offshore, outsource, and have a consistent set of metrics for determining quality that they can use for every contract, rather than having to have a different contract with some different support costs for every outsource and offshore contract. And by the way, it's a good thing for the outsourcers and the offshore companies too, because they don't want to have to support hundreds of different software quality metrics. Great to have a standard metric that they can depend on. But even more important is that it's automated. Non-automated metrics don't get used because they have to be done by human beings, and that costs money. The whole point of the CISQ process and the OMG standards process for adopting CISQ standards is to adopt only automated processes. Automated processes for counting the size and complexity of code, automated processes for discovering defects in code. Tremendously valuable for the IT organization. Even an IT organization that's insourcing, they still need to know that the quality of the software that they're developing for their own use is high. And process quality isn't enough of an indicator. You need to have artifact quality as well. The world does vary. So I've just come, just before this interview, from Asia. And Asia was slower to adopt the software development process metrics like CMMI, like ISO quality standards like ISO 9000 and ISO 14000. But they're all fully adopted in countries like Japan, Singapore, India, and China today. Since the adoption of those standards, process quality standards, was much more recent than the adoption of those standards in the West, I think we're going to see slower adoption there too. And I had a knockdown, drag-out battle with the top technical staff at a very large software development firm in China that told me that AFP just couldn't work. There was no way that you could automate function point count. This despite the fact that I showed them the standard, they could see it. And they said, well, you can't look for defects in code automatically, only human beings can do that. Well, I'm sure it's true that human beings do a better job than automated systems. There is no way that the 3 to 4 trillion lines of code that are currently running real systems in the world today are ever going to be all checked by human beings. So we have to do what we can do automatically. So yes, there are regional differences. We're seeing more interest in automated function point count and automated defect recognition now in the West. But there is tremendous interest in Asia, and unsurprisingly, a tremendous interest as well in the traditional large outsourcing and offshoring countries. Most of South America, India, and China, for example, they have very high costs related to different quality metrics with every contract that they're involved in. They'd like to bring down those costs by having consistent contracts based on consistent software quality metrics. It's in their interest, therefore, to have standards. And it gives them a way, potentially, to differentiate between each other. Today, having a high CMMI number doesn't necessarily differentiate you as an offshore or outsourcing company. So having another way to differentiate is certainly valuable to them as well. I don't think that it's fixed yet. So I have an unfortunate story of having been contacted by the head of IFPUG who said, which is more valuable, to have an international standard for function point counting or one that's automated? I'm afraid I told him the truth, and the answer is an automated one is more useful. It's lower cost, it's consistent, you get the same answer no matter how many people do the metric count. You get the same answer from the same person doing the count twice, which is not necessarily true for an IFPUG function point counter. So yes, there's pushback. Actually, more often the pushback I get is from organizations such as my recent trip to China, in which I was told, no, that can't be done. You can't automate function point counting. You can't automate defect checking. But of course you can. It's been done for a long time. What we're doing is standardizing. We're starting to see AFP deployments now. I can't talk about specific companies, but I'm aware of one in the telecommunications space and one in the manufacturing space. And in both cases, they've brought down the cost of measurements of complexity, and now that's sort of the denominator of the metric. Now we need the denominator. We need standard defect metrics. We need standard ways to find everything from buffer overflow to too much complexity in loops and go-tos and so forth in source code. And that's what we're concentrating on this year. We don't have that yet today. It's standardized. CISQ, the CISQ group has come up with 82 metrics of software quality, essentially patterns of good and bad software development. Those need to come through the OMG process so that they're standardized, recognized, and actually could become ISO standards through our publicly available specification process with ISO as well. So we're starting to see it. It's just beginning. And by the end of the year, I think we're going to see hundreds of organizations measuring the defects in their code and measuring the complexity and size of their code using standards that came from the CISQ process. CIOs want better, faster, cheaper. We used to say when I was a consultant, I know you want better, faster, cheaper, choose two. This is actually a standard that lets you choose all three exactly because it's automated. So it brings down the cost of defect checking. It brings down the cost of size checking. Increases the quality because you know where the defects are, you know where to fix them. And obviously it's faster because it's done by a computer rather than by a person. So we'll see pushback. We'll see people realizing that they need to change their processes. It's a business transformation issue. But I think that CIOs should be looking for both productivity and lower cost. And they're going to get that from standards for software quality. AFP is a standard. It's on the list to be sent to ISO to be an ISO standard as well, which will be important to organizations that find that they have to use ISO standards for World Trade Organization, WTO reasons. Especially once that happens, it will be very widespread and it will be heavily used. But the important thing is not whether it's a standard. The important thing is that it's automated. That means lower cost, higher quality. That's absolutely exactly what we're looking for. So yes, we're going to see AFP be a standard, and I think the only slowness in uptake today of the AFP standard is we've got that denominator, we haven't got the numerator yet. We don't have the standardized defect metrics, the standardized defect patterns and anti-patterns. You know, I often point out to CIOs that there's actually, well, there might be some activation energy, there might be some cost to adopting any standard, not just AFP, but any standard. The cost savings for automated standards are obvious, and the adoption cost is rather low. It's a piece of software, and you run it, and you don't have to hire extra people. You don't have to get any people certified. You don't have to have an organization certified. You simply run it, and you get a real consistent metric on the size of software. So, as is true with any new standard or any new technology, the usual thing is, choose a small project, something that's not in the critical path, try it out and make sure it works. That's true for AFP too. The difference is the cost of trying is near zero. It's not like you have to hire a platoon of consultants. It's not like you have to train up a whole group of people. It's simply the adoption of a standard that is fully automated, where you have a choice of vendors implementing it. And that's exactly what a CIO wants, a choice of vendors, low switching costs, consistent and automatable solutions. Clearly, AFP is out there, and it will probably have to be corrected or fixed here and there. The real future is going to be in those defect metrics, the patterns and anti-patterns of good and bad software quality. Those are critically important. As I say, the denominator of the fraction of defects per function point. You've got to have those defect metric standards. So that's the future, and this year we will have all 82 of the defect patterns and anti-patterns that the CISQ group has developed come through the standards process and be adopted as OMG standards. We'll also see changes over time, and changes in software quality standards are unfortunately difficult for users of those standards to take advantage of. I remember an article by one of the leading software quality companies about 4 or 5 years ago in a major international journal that pointed out that every time they shipped a new version of their software, all of their customers' software got worse because they were looking for new bugs that they hadn't looked for in previous versions. That's going to happen to us too. But the fact that we know about it ahead of time, that the standards are open to anyone, that the patterns are open to anyone, that anyone can participate, so that CIOs can actually participate in the development of those standards for recognition of defects and say, look, this is a defect that's costing me because I'm a manufacturing company, or because I'm a bank, or because I'm a telecommunications company. That is the opportunity to focus on the defects that you care about the most. So we'll see the same sort of pain of changing standards, but the fact that the entire process is transparent, open, and international and neutral, anyone can participate, that we expect at least half of the participants to be end users of these solutions rather than vendors, is very important. In fact, while I said OMG is about 50% vendors and 50% users, the Consortium for IT Software Quality, CISQ, has over 600 members today, and all but 10 or 15 of them are in fact users of this technology, not vendors. Even some unexpected ones like IBM, but IBM's IT department and national agencies, government agencies like the Department of Homeland Security in the United States and so forth. Banks and manufacturing companies and health IT companies and so forth are participating in the development of these defect standards and the automated function point standard itself. I'm very hopeful for the adoption of those standards.